Hello, everybody. Welcome back to a new episode of the Midnight Sessions. We're going to follow the same procedure. We're going to start with the ecosystem updates. Then we're going to go through some coding. And then I'm going to open the mics for questions and answers. In the meantime, you can leave your questions on the chat. Or if you want to just jump into the stage and ask your questions directly, I'm gonna enable the hands that you can raise at the end, and I can invite you guys to jump into the stage. Okay, so well, just wanted to confirm if everybody here is hearing me well. They can see my screen. Just double checking. Sometimes Discord doesn't want to show anything. Okay, 100%, perfect, Honorat. Okay, so let's start with the ecosystem updates. We're going to go through the same procedure. We're going to start with the blocks. This time, we're going to talk about an update regarding the hackathon. The last hackathon was regarding the ecosystem hackathon. So, Midnight, they just published this blog. So, let's take a look. This blog is regarding the author. It's Lauren Lee. And the title is Builders Rise to the Ecosystem Tooling Challenge. So in a previous session, I gave kind of a quick summary regarding the hackathon projects, but this time Lauren made a really nice summary of the projects. She provides some recommendation for future hackathoners. So let's take a look. Through this blog, she mentioned what are the criteria that judges take in consideration once analyzing those projects, right? And this same judging criteria is gonna happen for the next hackathons. So we take in consideration the impact that does this make building on Midnight easier or more powerful? There is reusability. Can other developers quickly adopt or extend it? There is a quality factor. Is that code robust, documented, and tested? This is something really important that a lot of developers they don't consider including in their project, which is documentation, right? Sometimes they put the code in there and think judges are going to have the time understanding to actually go through the code. And actually, this documentation it's what it's really powerful and transmit the whole idea and the architecture of your project in a really succinct way for judges to take into consideration. So this quality and documentation really important. Adoption potential. Does it solve a real need for Midnight developers? So in the last hackathon, there was these 5 categories: CLI tools, dashboards and user interface, integrations, developer experience, and NFT design. So let's take a look at some of those projects that won under these categories. So the winners for the CLI tool. So we have the winner, Scaffold Midnight. Scaffold Midnight is a zero configuration command line interface CLI tool that enables developers to rapidly set up CK-enabled smart contracts on Midnight. Creator Caleb Abneb developed the tool by creating small scripts to simplify his own learning process. The result is a one-command project bootstrap that reduces initial application setup time for over half an hour to just a few lines of code. So these scaffold midnights are starting to appear in the ecosystem and are really important because once a developers want to understand Midnight and start creating some smart contracts, they don't want to go through the boilerplate. They want just some scaffold projects. And the ecosystem is really rich regarding frameworks. We have Next, we have different front-end uh, libraries. So there's going to be a lot of scaffolds that are focused on some specific use cases. So, well, Caleb did a really nice job providing these scaffold Midnight. Judges were impressed by the significant time saving that this tool provides, allowing developers to configure a new project in minutes. Second place for this CLI tool category, uh, Midnight Node scripts. Let's take a look at this code. Midnight Node scripts created by Enigma offers a valuable collection of scripts designed to simplify the complex task of setting and monitoring Midnight nodes. So You can see the first project was focused on developers creating apps, and this one was focused on the SPOs, the midnight nodes operators. These CLI tools significantly lower the barriers to entry for node operators, making the process more accessible and user friendly. So this was regarding the CLI. Now, the dashboards and UI. First place, NBX. Let's take a look at his project. The team from NBX created Midnight MCP. So we are talking about artificial intelligence now, the connection. A model context protocol that simplifies interaction with the Midnight indexer. While the indexer provides a strong foundation for blockchain data, querying and interpreting that data can be difficult. Midnight MCP simplifies data access by translating it into human-friendly structure. So your IDE, for example, Cursor or Windsurf, are going to be able to talk with a indexer. So you're going to be able to perform like a automatic processes within your IDE, agentic processes, and be able to talk with the indexer. So really powerful, this MCP stuff. Judges commented that the tool is a good starting point for creating richer interfaces, and it's particularly useful for non-technical users. Okay, category integrations. The winner, MNN Midnight. Let's take a look at their project. This project from MNN Midnight turns the complex Midnight validator stack into one-click Kubernetes deployment. Really powerful. Helm chart packages the Midnight node, Cardano relay, DB-Sync, and other components into a single repository, expediting the process of running a validator on a cloud provider. So, what is the magic of this project? You can deploy everything on the cloud using Kubernetes, so it's scalable. Really powerful integration. The judges uploaded this as a useful tool for automating a complex process and making it easier for anyone to run a node. Okay, regarding DX libraries. Winner, Enterprise ZK Labs. Midnight Forge is a proposed education, collaboration, and compensation system for aspiring Midnight developers. The system uses a anonymous decentralized digital identity NFT to manage credentials, track educational progress, and approve experience. The project does not yet incorporate programmable privacy and zero knowledge proof, but it looks forward to allowing for selective disclosure of information in the future. Really powerful. They are combining three key topics when it comes to embarking developers, which is education, collaboration, and compensation. Judges appreciated the project's approach to accelerating education and developer engagement. Second place, Wipe. Wipe presents a sophisticated tool for the formal verification of compact smart contracts, leveraging predicate calculus and designed to support several programming languages. Judges noted this project's unique and forward-thinking vision, providing a strong starting point for formal verification with compact. Really powerful as well. Okay, so then Lauren provides some feedback for future developers that want to participate uh, during the hackathons. So the winning project demonstrated key strengths. Make it usable by others. Always when you're planning to do something, you have to kind of think what problem I'm solving, how this tool can be used by others. So think beyond the pitch, write clear documentation, record a compelling demo, structure your code for seamless reuse. Another key strength, prioritize creativity and real use cases. New applications and novel approaches always stand out. And stay focused. This is really important. During the hackathon, you need to know what are the people around you that can help you out. What is the time constraint that you have for actually building the product. So you have to stay focused. You need to understand how everything is gonna play out. A well-executed single-feature tool consistently beats an over-staffed app with imagined future functionalities. So this sounds really easy to do and implement, but actually it takes some thinking and planning before actually implementing something. Okay, so yeah, we appreciate this post, this blog, a lot of insights. Okay, now let's take a look at a Dave diary. This time, we're gonna go through this diary here that talks about how to connect a DApp to a Lace wallet. So we know that we have two types of wallets right now implemented within Midnight. We can run it on a node runtime, or we can actually talk with an implemented wallet through a browser. In this case, they are given as an example the Lace wallet. So here we're going to learn how to actually our browser can talk with the Lace wallet. So here they go through the process, and step one, it's detect the Lace wallet. Those that are used to uh, create applications within Cardano, the process works pretty similar. We have a injected JavaScript through the wallet to the browser, and we have to grab that injected code to actually call some procedures to the wallet. So in this case, the injected JavaScript is going to be under this object window and midnight. So we have to look for that object. So we say, okay, this is all this code is running in our browser. If we have this object window that midnight and specifically the Lace wallet, which is under the name MN Lace, for other wallets in the future, we want to have different kind of subdomains. So, for example, if we want to look for Lace, it would be window.midnight.mnlace. If we want to look for another wallet, let's say Eternal, for example, uh, it would be window.midnight.eternal, and that goes on, right? So if we have that object, means that we have the injected code from the wallet into our browser, then I'm gonna actually save that object under this variable mnplace. Okay, that's the first part. Then what I can actually do with this object, it's perform some methods. How do I know that I have those methods? So that's a standard, right? The same way that we have standards in Cardano, we're gonna have standards in Midnight. And just for reference, if we go to the docs, we can see here reference documentations. We have docs for Compact and we have for the Midnight APIs. Under APIs, we have this DApp connector API. So this is a standard, and this folder, it provides all documentation regarding how that standard works. So we can see here that, for example, for interfaces, we have this DApp connector API, DApp connector wallet API, DApp connector wallet state, and other stuff, right? So we can go through this documentation and understand how this standard works, right? So we know what are the methods available under that object. So let's keep with the examples. So in this case, we know that we have a method called isEnable. So we save the object the injected code under mnlace, and we call the method, I'm sorry, isEnable. So in this way, this is gonna tell us if the wallet is enabled or not. Let's find that method on the documentation. So if we go here, we can see that under these available methods we have isEnable. And it says returns a promise with a boolean showing whether the DApp is authorized to access the API or not. Excellent. So we have this result isEnable. Since it's a promise, we have to await further response. Okay, step 3, request access. So now we are going to call the method enable. Here it's isEnable, and here if it's not enabled, we have to enable it, right? So for that we call the method enable. This method, it's for those that have already used some DApp with blockchain. Normally when the DApp wants to connect with your wallet, there is a window that pops up asking you for permissions, right? So when this method is run enable, that's when this pop-up is going to happen. The wallet's going to ask you, user, did this DApp wants to access wallet. Are you okay with that? So this enable method, it's what that it's performing, right? So here it says, this will trigger a UI pop-up from the Lace wallet asking the user to approve the connection. Once approved, they gain access to a full wallet API interface. So this wallet API, it's going to be the wallet API interface. Okay, what is that interface? They don't say it here, but let's go to the documentation. And we can see here that once we enable, we have this API. And we want to have this DApp connector wallet API. If we see here, now we have all the properties of the wallet. For example, balance and proof transaction. We can uh, prove a transaction. We can uh, grab the state of the wallet. We can submit a transaction. See? Perfect. So now we're going to be able to see the state. We saw before that we have the state. So now with the wallet API, we're going to call the method state, and we're going to await because it's a promise. And by running that, we're going to have the state of our wallet. So let's see that we want to see the address of our user. So we're going to grab the state, and inside that object, we're going to have different properties. One of those are the address property. So in that way, we're going to be able to connect to the wallet of our user and read the address of our user. So we have it here, user address. This gives you the user's midnight network address, which you can use for different things. For example, to display in your UI. Step 5, get service configurations, optional. The wallet also exposes additional configuration metadata, such as service endpoints. You can fetch this like so. So this is something different in Midnight that we don't have normally in wallets in Cardano. That those that are having been following the sessions, they know that we have something called providers. So those providers are instances that we're going to use to actually deploy our applications. And these service URI configs are actually those links for those providers. So in our wallet, a user can connect to different instances, and we can change the URI for those instances. So the DApp developer, they can grab those instances by calling this method. Okay, so a final example would be like this. We first, and summarizing, right, what we have studied. We see if we have the object, in this case, the Lace wallet, then we grab the object, we save that object, and we call a method isEnable. And then we grab the state, and we are gonna console log the address of our user. And then with the config, we can grab the instances, URLs of the instances, and then we can just console log those URLs. And then here it says there's a quick checklist, and this enable, right? This enable is in case if it's not enabled, we can ask the user to enable that wallet for us to actually read this information. So you can see that connecting to the Lace wallet, it's pretty simple. We have just an object and we can call methods. Excellent. So now let's go through the academy. We are going in a really nice pace. We have already finished module 1 and module 2. And now we are starting with module 3. And in this module, we're going to start to learn what is zero knowledge proof, right? So in this first in this episode, we're going to start by reading the introduction to zero knowledge and commenting some stuff in the middle, and understanding some properties regarding ZK, and also understand what is the difference between interactive and non-interactive ZK proofs. So let's read this together. I'm gonna just go in here. So introduction to zero knowledge proof. A zero knowledge proof is a method by which a prover can convince a verifier that a certain statement is true without revealing any additional information beyond the truth of the statement. Really powerful. In other words, the prover demonstrates knowledge of a secret or solution to a problem without sharing the secret itself. For example, a CK proof could allow you to prove that you know a password without actually disclosing the password, or prove that you are over 18 years old without revealing your exact birth date. This seemingly magical property is achieved through clever cryptography, ensuring that nothing is learned by the verifier except that the statement is true. So this concept of CK, it comes back from the 1985 when the first paper was kind of developed for DCK proof. And as time went by, I mean, the process was optimized. And with Midnight, what they offer is that we have DCK proof embedded within a blockchain. So we have a prover and we have a verifier. And this verifier happens to be a node within a blockchain. Really powerful. Key properties of CK proof. All zero-knowledge proof protocols must satisfy three fundamental properties. Completeness. If the statement is true and both prover and verifier follow the protocol honestly, then the honest prover can convince the verifier of the statement is true. In other words, valid proof will be accepted. And this is obvious, right? Nobody wants to send a proof and the verifier take that proof as granted, as true, actually not being true, right? So yeah, it has to be completeness. Soundness. If the statement is false, no cheating prover can convince the verifier that it is true. And zero knowledge. If the statement is true, the verifier learns nothing else beyond that fact. The proof yields no additional information about the secret or data itself. These properties guarantees that a CK proof is both trustworthy and privacy preserving. Okay, so these three are really important. It's kind of obvious, but we have to make sure that the framework, the protocol itself, uh, comply with these three properties. Okay, now let's understand what is the difference between interactive and non-interactive CK proof. Early zero-knowledge proof were formulated as interactive protocols. In an interactive CK proof, the prover and verifier engage in back and forth conversation, often multiple rounds of challenges and responses to complete the proof. So you can see that this cannot happen in a blockchain, right? I mean, the users, the nodes, they are not always connected. They cannot just keep talking. The users, they don't keep talking between each other. Normally, what happens is the user sends a transaction and it just waits for that to happen. It can just go away, and the node eventually is going to process the transaction. So we need for blockchain, it's kind of non-interactive. So this interactive, it's just in the old ways, in the past. Let's keep reading. Uh, some a classic metaphor is the Alibaba cave. Imagine a cave shaped like a loop with a locked door on one side. The prover claims they know how to open the door. The verifier waits outside and randomly asks the prover to appear from either the left or the right path. If the prover can always comply, even across many rounds, it's convincing they know the secret without ever revealing the key itself. Okay, now let's see the non-interactive. More modern applications often use non-interactive CK proofs. A non-interactive CK proof allows the prover to create a single proof artifact that the verifier can check later with no further input from the prover. Non-interactive proofs are typically achieved by using cryptographic tricks. For example, fiat Shamir heuristic, which replaces a verifier challenge with a high function. So this interactive, it's the kind of secret proof that we use for blockchain. Okay, excellent. So we already know what it's a secret proof and the difference between interactive and non-interactive. And we know that for blockchain applications, we're actually using this non-interactive. where the prover and verifier, they don't need to be in constant communication. Excellent. Now, let's go through the catalog where we start analyzing some projects made by ecosystem partners. So this time, we're going to take a look at some things that OpenZeppelin and NMKR are doing, and it's regarding standards. What kind of standards? Tokenization standards. So OpenZeppelin, they just released a post where they mention OpenZeppelin compact contracts for Midnight Network are live for public testing. Take a look at the first smart contracts primitives for programmable privacy on Midnight. Fungible tokens, NFTs, initializable, and possible utility. So we are gonna go through these documentation and code later on in detail, but let's take a quick look at their repository. So we can see here that OpenZeppelin, they release some contracts for standards of some type of tokens. In this case, they have the fungible token, they have the multi-token, and they have the non-fungible tokens. And in here we have a compact, right? So what they did in a nutshell, they implemented these standards that we have in Ethereum, ERC20, ERC721, and ERC1155 in Midnight. So there, it's kind of a mirror. What Ethereum did with those standards, now we're going to be able to do it in Midnight. And NMKR, they did something similar. They created also an NFT standard, and they have this post. NMKR, it's implemented NFT minting on Midnight Network. We are building the tools for creators and developers to mint NFT natively on Midnight. As part of this work, we've released an open NFT standard tailored to Midnight confidential smart contracts model. And here's how you can contribute. So they provided the GitHub, and they have this standard. They call it Midnight Token Standard. As opposed to OpenZeppelin, that they kind of create that mirror for Midnight using some Ethereum standards. NMKR, they created this Midnight Token Standard that they put everything together and divided in non-programmable tokens and programmable tokens. We're going to study all these in the future, but they mentioned here that they took in consideration the Ethereum standards and also some Cardano standards, SIP25, 68, and SIP143. So we're starting to create these standards. So this process is going to be something really nice to watch. And with Midnight, just to provide some context, we are going to be able to actually, we have the properties of a global state and a local state. CSwap, it works pretty much like a UTXO. And Caixina, we have this global state. So we can create standards that kind of simulates what we have in Cardano, but also what we have in global state blockchains like Ethereum. So yeah, this is gonna provide a lot of flexibility for users and applications to create these tokens. So the importance of standards is to actually come out with common standards for everybody to follow, and third party, for example, wallets and applications, they can understand what we are doing. Right? So this standardization is going to be really important. So perfect. This is that regarding the ecosystem. Again, we're gonna go through these standards later on. It's gonna take a while to go through the code, but just wanted to give some context right now. Excellent. Now, regarding the code, let's open our IDE, and we are studying this Midnight starter template, right? So we finished the last episode studying all the functions regarding the Contour CLI API file, where we learned all the different functions uh, to actually interact with the instances of Midnight. What we're gonna learn now is how to actually talk with the blockchain, how to create a application. But before creating an application in a actual user interface, we're gonna create a TUI now, which is a text-based user interface. For that, we're gonna create that code under this file CLI, and we're gonna use that the functions that we started before in the API plus the counter folder where we created our contract and we compiled it. So excellent. First, we have to understand here at the bottom, we have this function called run. So this is kind of the starting point to run our TUI application. So let's study the function. We have the config file where we have all the URLs of our instances. Then we are passing the logger instance and we are passing the Docker environment. Where these parameters coming from, uh, we have different ways to run our application. In this episode, we're gonna learn how to run our application as a standalone mode. So if we open this file, standalone, we can see here that we are calling that function that we're studying right now, which is run, that it's under the CLI file. So we are passing the config, we are passing the logger, and we are passing the Docker environment. So the config, it's coming from the standalone class that we have already studied, and it's coming from the config file. Then the Docker environment, we're using this, this library called tested containers that allow us to actually spin up Docker instances programmatically. So in this case, we are defining the Docker environment using this library, using this YAML file, the standalone YAML. If we just open that YAML, just to give a context here, we can see that we are going to use three services. The first one is the proof server, we have the indexer, and we have the node. So we're actually going to spin up those three services. Excellent. So we are defining the Docker environment, and then we are defining the logger. The logger is going to be created using this function, create logger. This function is coming from this file, logger utils, that we can see here. This is just boilerplate, and we're using some node processes to create a logger. Later on, when we execute the transaction, we can see here that this function here is actually going to create these files, this folder called logs, and we're going to be able to see different logs of what we are doing while executing transactions. Excellent. So in this way, we are creating this instance of logger, and we are passing to the function run, the config, the logger instance, and the Docker environment. Okay, let's go back to the run function. So we have this config, logger, and Docker env, and we are just initializing the logger. And now we are calling the API. What is this API? This is all the functions that we have studied during the last 3-4 episodes of the Midnight sessions. This API, it's coming from the file API, where we have all the functions that we studied before with the different methods. So in this case, we are just calling this API as a whole, and then we can execute methods that are the functions that we declare under this API file. So in this case, we are just calling the set logger. So we can click here just to make sure what this function is doing. And we see here that we are passing our logger, and we're just initializing the logger instance. Excellent. Now we are defining a readline interface. So we're using the create interface. This is a library again. So you see create interface. We're using this node readline promises. And this is actually the tool that we use within Node to create a TUI, a readline interface. So here at the bottom, when we run here at the command line interface, Here is going to appear commands and questions for the user to actually to read and input some commands, and we can read those commands and execute something in our code. For that, we're using these read lines commands, create interface. Excellent. So we are creating this create interface. We're passing the input and the output and the terminal true. This is just boilerplate, just for us to have this read line interface instance. Now we're gonna declare this environment. And what is gonna be this environment? If we have a Docker environment, when we're gonna have that, remember when we started the tested remote initialization file, if we're actually going to spin up some instances, we're going to have to pass to the run function some environments. If we don't need those environments, we're not going to pass anything. When that's going to happen, when we want to, for example, run an application using remote configuration, instances that somebody else are hosting and running in the cloud. So we don't need to spin up those instances using Docker. So we don't pass an environment. But if we pass an environment, it's because we want to host and run those instances using Docker in our local machine. Okay, excellent. So if we happen to pass this Docker environment, then I'm gonna call this method app. So what is this? What is this method doing? It's actually speeding up those instances and running in Docker. And the result it's an environment. Excellent. Then I'm running these map container ports. That what it's actually doing this, it's I'm just grabbing the port of the containers within Docker to be able to expose them to our user. So I'm just updating the ports. So now and then when it's updated, I just put in the result to the actual config indexer URLs. Excellent. So this is just kind of boilerplate. It's gonna work the same for every TUI application that we do. And now the fun things happen. First, we want to have a wallet. How we get a wallet? We're gonna call this function build wallet, and we're gonna pass the config and the readline interface. What is this function? If we go up here, we can see that we find this function build wallets. So we are passing the configs, we're passing the readline interface, and if this config it's of type standalone config, then I'm gonna build it this way. I'm calling the object API that is coming from the file API here, and I'm calling the method build wallet and wait for funds. This is a function that we have already studied. So let's take a quick look just to remember. See, build wallet and wait for funds. As a result, we're gonna have an instance of our wallet and resource. See, we studied all this. We're passing the configs and we are passing a Genesis mint wallet seed. What is this variable? If we take a look here up in our file, we are initializing that seed phrase for our wallet as a number 1. A lot of zeros and at the end a number 1. When we are running our application in standalone mode, this is actually the seed phrase where we're gonna get all the funds from. So we don't have to, if we select another seed phrase, we're gonna have a wallet, but there's not gonna be any funds at all. If we input that seed phrase that ends with 1, then automatically we're gonna have some default assets within our wallet that we can use to actually interact with the local blockchain. So excellent. So in this case, what we're doing is we're initializing that wallet using that seed phrase, and then I'm just getting into a loop while true. I'm just gonna execute this loop infinitely until it exits, and I'm running a command, a method called question of the readline interface, and I'm passing these questions, wallet loop questions. See, we are listing here the questions that we want to provide to our user, and we want to ask them, you can do one of the following. Option number one, build a fresh wallet. Option number two, build wallet from a seed. And option number three, exit. So the user is gonna see that interface, and they're gonna input one, two, or three, and they're gonna press enter. So when that happens, I'm just gonna grab the result in this variable choice, and then we're gonna run this switch choice. And in case the user selected the option number one, I'm gonna execute this. In case the user selected the option number two, I'm gonna execute this command. And in case they selected three, I'm gonna run this command. So what was option number one? Option number one was build a fresh wallet. Let's see. Number one, it's gonna call the API, the function build fresh wallet, and we're gonna pass the config. So what is this build fresh wallet? Just let's remember. If we go to the build fresh wallet function under the API file, we can see that we are calling a build wallet and wait for funds, which is the huge function up here that actually builds the wallet, and we have to pass a seed. See, we this is the function to create a wallet, and we have to pass the config files that we have the URLs, and we have to pass a seed. So in this case, that we want to build a a fresh wallet, we're running that function, but for the seed phrase, what are we doing? We are actually creating a random seed phrase for our user because they don't know what seed phrase they have because it's a fresh wallet. So we're gonna create a seed phrase for them using these random bytes, right? It creates a random seed phrase. So perfect. In this case, we are using this build fresh wallet uh, and passing the configs. If they select option number two, which is build a wallet from a seed, in this case, I'm running the command build wallet from seed. Where is this function coming? You see here that we have another function, build wallet from seed. That's in that case, we are gonna run the method question from the readline interface, and we're gonna ask our user, enter your wallet seed. Okay, you don't want to create a fresh wallet, that's okay, but you have to tell me what is the seed phrase that you want to build your wallet from. So they're gonna enter something on the CLI. When they press enter, we're gonna save that value under the seed variable. And then we're gonna call again this function, build wallet and wait for funds, and we're gonna pass this seed phrase that the user just entered. Excellent. And as a result of this build wallet, we're gonna have an actual wallet interface built using a specific seed phrase. It's either one automatically created by us, the developer, or some seed phrase input by our user. So let's go back to this build wallet. So we build a wallet using one of those options, and then we just store it under wallet. Perfect. So now we have the wallet. What we do now? The whole application is just this, right? Once what we've done before is just initialize our wallet and have some logger and the Docker environments, and we have a spin up our instances. So the actual application exists in this line of code. So if the wallet is not means we have a wallet, we are gonna run the config providers using our wallet instance and the config files, and we're gonna have the providers. So what are the providers? We have already studied that. It's the way we're gonna be able to connect our logic with the actual instances and execute the transactions. So we have 6 providers: the node, the indexer, the proof server, the wallet, the private information, our ZK config. Excellent. Having the providers, now build the main loop of our application. So this is our application, the main loop, providers, and the readline interface. What is this main loop? So let's take a look. The main loop, if we go up, we can see here. So we're passing the providers, the interface, and we are calling this function, deploy or join, and passing the providers. What is this or join? We are creating this loop. We can iterate with different functions. And then we are asking our these following questions, deploy or join questions. So you can see here we have these different questions, and we are asking the user the following. You can do one of the following. One, the counter contract, or join an existing counter contract. On two, and three for exiting. Excellent. So depending on the, we're gonna execute the different commands. For case number one, which is new contract, we are gonna call the deploy function from the file and passing the providers and the initial private information. If we remember this, we have already studied it. We have this magical function called deploy contract from the midnight.js libraries. And we are passing the providers and then passing the private state. So we are initializing this private state as private counter 0. Why this format? Again, if we remember the way it's structured, our private information, we can go here to the contract and see here that our private information, our witness, is of this type, an object, and it has a private counter and a value. So in this case, we are just initializing that value to 0, since we want our counter to start at 0, right? Okay, so we call this deploy. If we want to join, option number 2, we are gonna call the join function. Where is this join function coming from? Again, here we have this function. So we are asking our user to tell us what is the contract that they want to join. If we want to deploy, we're going to create a contract from 0, meaning we want to create the address of that contract. But if the user wants to join a contract, they have to provide us with the contract address. So we are asking the user here, what is the contract address in hex? Saving that result in this variable contract address. And now we are calling the function join contract from the API file. If you remember, that function is this one, and we are using this magical function coming from the midnight.js libraries called find deploy contract, and we have to pass the providers and we have to pass the contract address. So we are passing the providers and we are passing the contract address. Excellent. So in this way, we are able to deploy and we are able to join. And if we want to exit, we just return null. And then once we join or we deploy, the result of this function, it's going to be a deploy counter contract. So we go back to the main loop. By running this question, we want to have this choice, right? And with this choice, here, when we're running this deploy or join, the result is going to be of deploy counter contract. And now, if there's no counter contract, okay, I'm not going to do anything else. Otherwise, I get into this loop. And now I'm going to ask my user the following questions, main loop questions. You can do one of the following. Increment, so our contract, now we have a contract and we have the methods to actually execute something within our contract, meaning the circuits. So for the contract that we've done, we only have one circuit, which is increment. So we can increment, or option 2, you can display the current counter value or exit. How do we do that in code? So once we have the return of the deployment or joining a contract, we have this deploy counter contract object. So we're going to use that object to actually perform some methods. So we're going to enter this loop. In case the user selects option number 1 to increment, we are going to call the increment function of the API folder, and we're going to pass the counter contract, which is of type deploy counter contract. If we remember this function, let's take a look, is this magical function that we are passing the return after deploying or joining our contract, and we are executing the circuit by getting the deploy contract, call transactions, and actually calling the circuit, which is increment. So in this way, we are incrementing our counter. For option number two, we want to display the state of our contract. So now we are calling the function display counter value, and we're passing the providers and the counter contract, which is the result of deploying the contract or joining the contract. If we remember, this function is this one, where we're using actually our providers, which is the indexer. So we are getting the state of our indexer, and we're transforming that state into a type specifically of our contract, and we can read the counter value. So see, we're pretty much using all the functions declared on the API. And with that, we have all our applications. We are providing the option for the user to create a wallet, to join or deploy a new contract, and within that contract, they can execute circuits or they can see the actual state of the contract. Excellent. So that was a lot of information for this episode. What we're gonna do in the next episode is to actually execute this code, and we're gonna see how the transactions are created, what are the values that we get from the proof server, the time that it takes to actually execute the transaction, understand the results. So that's what we're gonna understand in the next episode. We're gonna go through the actual transaction process using this tool. Excellent. So now let's go to questions and answers, discussions. I'm gonna enable here the option to for the hunt in case somebody wants to jump into the stage and also any questions, or otherwise I'm gonna take a look here through the questions section here in Discord. So well, Johnny wrote here some comments. I'm gonna read them. So John mentions EdMaker is making standards for NFTs. On Midnight, those having opinions on DID and NFTs should submit to the repo that EdMaker is providing for feedback for the conversation on DIDs and NFTs on Midnight. It is vital that we consider as many use scenarios as possible in order to make useful standards that are as relevant as possible for the longest time. And he's providing the link, and then he continues and says here and mentions something here. I would urge everyone to share their thoughts on how they might use dynamic NFTs on Midnight to help make the best standard possible. We want to make DIDs and NFTs on Midnight very modular, allowing latitude for lateral changes as fast technological changes and shifts occur. But more importantly, we should be efforting to a completely untraceable DIDs and wallets for inception to implementation. Let's path the CBDC nightmare. Yeah. No, yeah, for sure. John. John wants to join the stage. I'm going to speak.
Hey, John, brother, good morning.
Hey, John, what's up?
I had a quick question regarding ZK proofs.
Yeah.
So when we're talking to like normies, right, and we are trying to describe what a ZK proof is, what analogy can I use? So let's say we have a scenario with where we have the ZK veil, okay, and then on the private side is a red ball, right? And then from the public state, we're asking, is the ball red, right? And the ZK proof confirms the Boolean yes, right? How can we explain in a simple analogy to a normie why they should believe that the ball is red?
Okay. Well, the John, the actual example that I've seen the most people use when explaining CK proof that actually solves a real use case and a common use case actually, it's this 18 years old problem when buying something, right? For example, alcohol, right? So you have to demonstrate the seller that you actually older than 18 for them to sell you alcohol. Otherwise, they cannot do that, right? The only meaning way right now to demonstrate that it's showing your actual ID. And with that ID card, it comes all other information that it's not relevant for the seller, like your address, your surname, where you live, where you, and other private information, which you don't want to show that to the seller. You just want to demonstrate that you are older than 18. So right now there is no way possible for that because you have to show that ID and the seller see, okay, this ID it's legit, and then he only wants to see your birth date, right? So with CK proof, there is gonna be a way to actually demonstrate to the verifier, in this case the seller, that you are older than 18 without having to show any private information at all. You just the verifier is gonna have this boolean yes or no, and they're gonna be okay. They're gonna trust that proof because it's under this CK proof framework. So yeah, that's kind of the example that I normally use to explain CK proof and why it's important and useful.
Okay, thank you so much.
Perfect, John. Well, John, I take I read your comments regarding the standardization. These topics are really important, and what we want to see in the future, something that it's in process right now within Midnight, and we're gonna have some news in, shortly. It's regarding the MIP process. So as in Cardano, that we have Cardano improvement proposals, in Midnight, we're going to have the same process. We're going to have Midnight improvement proposals. So we're going to have MIP 1, MIP 2, MIP 3, MIP 4. So what OpenZeppelin and sharing here the links, what OpenZeppelin and NMKR are doing right now here, they are kind of creating these GitHub repos with the code and the standards they have thought about it, right? And they are sharing it with public. What what is going to happen next? It's actually these projects and the community get together and discuss, right, these standards, and the final version and the authorized version standards. They're going to have to translate into a MIP standard. So we're gonna have these MIP 2, MIP 3, MIP 4, right? So yeah, this is something that we're gonna see how this takes place, and it's gonna follow this procedure that you mentioned, John. Right? It's first they're giving they're giving this information to the public, to the community. We're gonna have to revise it, discuss. There's gonna be some discussion in the middle. There's gonna be some first draft within this mid process. The reviewers are gonna go through the process to make sure everything is compliant, and then some specialists within Midnight Core team are gonna go through the code as well. And once all the checks passes, then we're gonna have a standard, right? In Midnight. And something that I'm really looking forward to see how it evolves. It's these standards of tokenization, because in Midnight we actually have uh, we are able to create tokens that pretty much looks like Cardano tokens but with privacy. But actually we can create these tokens that looks like, for example, mentioning one of the global state blockchains, Ethereum. So we can combine these different standards and kind of match them together, plus adding the privacy feature. So yeah, it's gonna be something really nice to see how it evolves, and I'm really glad that these two projects starting creating these frameworks. And in the process, I received a lot of feedback and questions from the community, from projects that are actually building their own standards. So we're gonna see how different people imagine the tokenization, and at the end, there is different factors that we're gonna have to consider, right? One is the optimization, flexibility, and actually interoperability, right? Because if we follow the same standards that other projects are doing, for example, Ethereum, Cardano, we might be able to easily integrate our tooling to those ecosystems. Okay, not sure if we have any other question requested. John has no speaker. Um, well, I think that's all the questions for this episode. So, well, next episode we're gonna continue studying the transaction process. So next episode is gonna have a lot of really nice stuff. It's we're gonna we're gonna put everything together that we have learned so far, and finally execute a transaction on the Midnight standalone network. So see you next week. Thank you all. Bye bye.